Okay, so here we are in the last part of section 3.3. There was a lot of great information so far, and most of it is we've been looking at an equation to find some information about a parabola. We were able to find a vertex or find the intercepts, find the axis of symmetry. This time we are gonna look at some information like the vertex is 1, -5, and they want us to write the equation. So now we're gonna kind of go backwards a little bit. If we have a vertex and we also know a y-intercept, I think we should start off writing this equation in vertex form. So that would be y minus k equals a times x minus h squared. Or I can bring the k over here. There's a couple ways that we can do that. Y equals a times x minus h squared plus k. I think that's the way that we're used to looking at that. But if the vertex is 1, -5, I know that these are my h and k values. So if I plug those into the function, into the equation, I have a, which I don't know what a is yet. So I have x minus h, so I have x minus 1 squared plus k, which is -5. Now, to really complete this equation, I need to know what the a value is. This is going to determine if it opens up or down or fat or skinny. So since I know another point, the y-intercept on my graph, the y-intercept, remember x is 0 and y is the value, so that would be -3. So if I plug these in for x and y in my equation, the only variable I'll have left is a, and I can solve for a. So if I plug those values in, y is -3, that equals a times x, which is 0, minus 1 squared minus 5 for k. So if I solve for a here, this is going to be 0 minus 1 is -1, squared it, that would be 1. So 1a equals, if I add 5 to both sides, a is going to equal 2. Okay, so that's the number I'm going to put into my equation for a. So here would be the equation. Y equals a, which is 2, times x minus h, which is 1, squared, and then minus 5. So there is our quadratic equation. They also ask us to graph. So let's make a graph. I know that my vertex is at 1, -5. And I also know that the y-intercept is -3. In every quadratic equation, or every parabola, remember you have that axis of symmetry that goes through the vertex. And all the points that are not the vertex are reflected over, so they're the same distance from the axis of symmetry, but on the other side. So this point right here is going to have a reflection point that is 1 unit directly across from that. All right, so it doesn't ask me to find the x-intercepts, but I can now just kind of make a sketch of what this graph might look like. Okay, so then we have one more. This completes this long section 3.3. Here it asks us to determine whether the quadratic function that's given has a maximum or minimum value and to find the location of the maximum or minimum. Well, if I look at the previous example, looking at maximum or minimum, that would either be the highest point on the graph or the lowest point, and it is determined by where the vertex is. So this here would have a minimum value, and the minimum value is the y coordinate, which is -5. All right. If the vertex is on above the rest of the parabola is pointing down, this would be a maximum value, and it would be wherever the y coordinate is. So this one is a minimum value of -5. It happens when x is 1. All right, so in this equation, if we're looking at max or minimum, we need to find the vertex. So to find the vertex, we need to find minus b over 2a. That's going to give me the x coordinate of the vertex. So minus -4 is +4. I should say the opposite of -4 is +4 over 2 times 1. So the x coordinate of the vertex is 2. So here's my vertex. The x coordinate is 2. The y coordinate is going to be what the function equals when I plug in 2 for x. So I'm going to have 2 squared minus 4 times 2 and then minus 5. So this is 4 minus 8 minus 5. That would be -9. So my vertex is at 2, -9. If I just do a quick sketch here, here's 2, -9. It's going to point up because my a value is positive, so it's going to go up this way. So this is going to be a minimum, and the minimum value is the y value of -9. The location, I'll do this up here. So the minimum is -9 when x equals, and we're looking at the x value, and it would be when x is 2. All right, so that kind of wraps all this up here, and we will continue on next time with looking at some data involving quadratic functions.